Welcome, everyone. Thank you for joining us for this session. As I mentioned, and you probably have seen us all running around here. My name is Henry, and that's Ted. You've probably seen Ted. He's one of our most famous presenters here, so we're having him work extra hard. You've probably seen us scurrying around trying to get all these connections going. We're doing our utmost to actually show you how to deploy to 3 different types of devices today, and we're going to see a demo for a 4th one. So we're going to be doing a lot of on-stage switching between monitors, so please forgive us in advance if you see the wrong monitor at some point in time. We're hoping to get through the demo quickly so we can get questions. But if you have a burning question that cannot wait, it's OK. You can stop us. We'll take 1 or 2 as we're going through the demos. We understand that we're switching between very different spaces quickly in terms of the type of devices that we're going to be targeting. And if you have something that you want to ask, just shout a question or stand up. I'll be glad to repeat it and take it. Great. So without further ado, some agenda. I'll be giving you a brief intro about how we think about AI at Microsoft on the edge. And we're going to be doing a demo on the heavy edge. We're going to be looking at moving down the spectrum to a smaller device that's a Minnow board. We'll be doing a demo with a drone, and then we'll be doing the official introduction of the Vision Developer Kit that you probably saw at Satya's announcement. And as I said, questions are more than welcome. So just to get an idea, if you can raise your hand if you are primarily an IoT developer. Oh, great. That's a fair number of people. Excellent. So we're going to spend, one more if you are an AI developer, if you're doing some type of machine learning or AI. OK, fewer. So we're going to spend a little bit of time explaining the core principles behind AI development. And in fact, what you saw at the beginning when I was taking a video of Dave, it's really our mock of what it takes to collect data. So that was our data collection, and we'll see how it hooks up into the rest of the presentation in a second. But when you come to Microsoft, you're looking at our products, both on machine learning and AI, and you're probably in one of 2 broad categories. You're either looking to build your own or customize something that we have given you, or you're just looking to consume. If you're looking to consume, you're going to be going to cognitive services. You're going to be given a REST API. You communicate with it, and your application is AI-enabled. There have been a couple of great sessions on that. We're not going to be talking about this use case. We're going to be going down the rabbit hole of custom builds. Now, when you're building it on your own, you have 2 options. You can either go code first, or you can go and use visual tooling. We had announced a couple of years back a visual tooling solution that we called Azure ML Studio. We're not going to be talking about that. We're going to be sticking to the left. We're going to be talking about code first. Now, when we're talking about code first, we're talking about the different components on that platform. And you could be targeting either on-prem with ML Server, and that will support your SQL Server and Hadoop. You could be going directly to the cloud. You've seen a lot of talks today about the cloud. You could be going to the edge, which is what we're going to be focusing on. And in the future, you will be going to mobile as well. You'll see a little bit of development and deployment to mobile, but it's just a teaser of what's to come. As I mentioned, the cloud has been broadly covered. We'll touch some of those components as we're leveraging them to train models, but our deployments are going to be primarily going to the edge. In fact, all of the demos are going to be going to the edge. So when we think about the development lifecycle in Microsoft, we look at the AI development lifecycle, and it starts with data. So you've heard it in many of our talks yesterday and today. Data is the most important component to get high-quality AI. Now, gathering data and labeling it, it's very complex. So what you saw when I took the video from Dave is me gathering data. I'm going to be doing transfer learning, which means that I'm going to be using a model that has been pre-trained and teaching it to recognize Dave, along with other things. So gathering that data can be challenging, but it doesn't have to be a showstopper. There's very interesting ways to crowdsource that data. We started right now with taking these videos. You'll see that there's more and more people that are issuing applications for free where you give your data. There's no mystery on why a lot of companies have free photo sharing apps where you can actually providing this data for companies to leverage. As part of these efforts with data, and the cursor doesn't work, you're going to be doing some level of training with that data, and that means that you need to do data curation. Not all the data is good. Some of the data will need to be changed, and you will be needing to modify that data. Based on that data, you will create a new model, and that model will be packaged and deployed with an application, and then when the application is running, data will be collected. You'll notice that there are 4 personas that we identify in this. Data engineers, any data engineers in the room? Great, because I have nothing to show you for data engineers. Data scientists, any data scientists? Okay, even fewer. We're going to be assuming that a data scientist has already worked on, and in fact, many of them have created very interesting models and networks that we can reuse, so we will be reusing that. The vast majority of the people in the room are app developers. We're going to be focusing squarely on app development. And the DevOps or model manager is a new role that we're seeing surface as more and more models are being deployed into the cloud and the edge. When you have thousands or hundreds of thousands of models that are deployed and you're rotating on a daily or weekly basis, you have the need for a persona that is completely dedicated to monitoring this ecosystem. So Azure Machine Learning satisfies all 4. We're going to be focusing on the app developer primarily today. So as I mentioned, I wanted to recap a little bit, what does machine learning imply? So in machine learning, and we're going to be talking about neural networks to make it even more focused, starts with an original network that you could either have created on yourself or you could be reusing if it was created by someone. In our example today, we're going to be using a mobile net, very popular network. And that network is really a series of layers that are abstracting information about the particular subject matter. In this case, we're going to be seeing 3 types of scenarios. We're going to be seeing images being inferred. We're going to be seeing thermal sensor data being inferred. And we're going to be seeing satellite imaging being inferred. So when you have that network, you go and you leverage a framework. Now, there are several frameworks out there. TensorFlow, Caffe are 2 of the most popular right now. Caffe 2, actually. PyTorch, Keras. These frameworks are really just compilations of libraries that help you either create these networks or modify these networks. In order to modify these networks and to replace those last layers of the network with the information that's specific to what you're creating, you need a lot of information. In this case, these are additional images. Those images that we just took are going to be part of that information. Once you have this data, you can run the algorithms to retrain your network, and then is when you get a model. So when we talk about a model, we're talking about this trained or retrained model that has gone through this process of taking the network, leveraging the images, using the framework, replacing the last few layers of that couple in this case, the last 2 layers of that network, and it gives you a new model. Now, when you have that model, you need to use it. The best way to think about it is think of it almost as an asset in your library, and you include that in a project and create what we call a scoring file. Scoring file is a term that comes from data scientists in machine learning. It really could be an application, a web service definition. It's some way to take input and give it to the model. The model is executed inside of a runtime, which corresponds to the framework you've used, and that is your application. When you have your application, you want to deploy it. Now, you have 2 options to deploy it. You can either deploy it with Dockers into the cloud, or you can deploy it with those same Dockers now to the IoT edge. You could also go native. You will notice that we have a reference between message passing up here and co-located. Most of the models that are deployed on the cloud are message passing, meaning that you put a service and the model is doing only that. It's basically getting information, processing it through the model, and issuing a response. And it is a service that is offered to the rest of the network. You can, in fact, and you will see in one of our demos, deploy the same way on the edge. So you could have a central node that is providing services, and you have systems that are providing it information. And it scores the data, and then it issues results, either to those systems or upstream to the cloud. This works well with systems that are doing what we call batch processing, meaning that you capture a bunch of data, or a little bit, and you pass it, it's processed, and a decision is made. It's not real time. As you see more and more of these devices, like if this guy was doing that, it'll be fairly challenging for him to avoid a human, because by the time that the message has gone back and forth, he's probably hit me at that point. So that's what we're calling a co-located application. It's running right next to where the sensors are, and it's operating within it. IoT Edge does a great job of allowing you to have that message passing infrastructure and have the inferencing component or this scoring component either on device, on the hub, or on the cloud. The challenge is that if you're doing that with things like images that need to be processed at 30 frames per second, even the penalty that you pay on going up and down the stack every time that you write a message within the same machine is too much. So in that case, you will be creating an application that incorporates both the logic as well as the business logic as well as the model, and you run it inside of that Docker container. That's what you will see us doing for the camera. So why am I telling you all of this? It's a little bit of nuance, but it makes the whole world of difference. Traditionally, if you go and you look at any tutorial online, it will be telling you how to do these web services. But in IoT Edge, especially if you're trying to run on device, you have to make decisions in terms of even milliseconds of delay that could be too long for you. You get to decide which of the two approaches you're going to follow, and you're going to see both here. Our platform supports both. But that's why we focus so much on, it's running on device versus going to the cloud and so on. And of course, you can also run it native. You see an example of that as well. We will be running attached to or as close as we can to the sensors on native, and that's a Windows application. You'll be seeing that demo as well. Fairly heavy amount of data that I've transferred to you here. So what is really the key value proposition that we have for you? We are looking to provide you with an ease of discovery. What that means is that there's a large number of models that are available for you to choose, both to retrain and in your organizations as they ramp up. There will be tons of models that are created within the organization, and you need to be able to find them. We currently maintain a gallery of models for different applications inside of Azure Machine Learning that you guys can leverage and reuse. But we're also empowering companies to create their own repositories of models, and we help you choose between those models and find them in your organization. Now, once you have found them, you want to integrate them. And to integrate them, you're going to use the tools that you're familiar with. You're going to see that most of machine learning has traditionally been done in Python. It's traditionally been done just in Jupyter notebooks. It hasn't been done in the tools that you're most familiar with. That's why we have such an emphasis on VS Code and Visual Studio, as well as an SDK that you can leverage both within your tools or other open source tools like PyCharm and so on. Once you have created your applications, you want an ease of deployment solution. What that means is that we have this concept that I'll explore in a bit, by which you are able to think about your models as assets that can be deployed anywhere in the cloud. And we give you the ability to make this deployment either using your command line, SDK, or a web interface. And the reach of deployment, you'll see the reach of where we're deploying. We're going from, I don't know if you can see it here, on this side we have that server. We're going from that is really heavy edge, from that heavy edge to this guy, to the drone, and to our new camera. The reason that we can do that is that we understand enough about the model so that you don't have to. So what we'll do is we'll train a model that will be deployed to all of these devices. And finally, because we have helped you through your journey and we have an understanding of where you've made these deployments, we provide a single pane of glass to monitor the web services that you have deployed, the heavy edge applications you have running, all the drones circling around in your company that are running machine learning models. They all might be using the same model or slight variations of it, and we allow you to look at them through a single pane of glass and be able to manage them. Now, you've heard me talk about heavy edge and light edge. What does that really mean? These tables helping to illustrate that. So Azure and the cloud, we have primarily CPU and GPU systems, and now we have Area 10 FPGA-based systems. So that's heavy iron. We have thousands of servers running for you, and they are running these models natively to Windows, or when it's a native Windows model, like in the FPGA, or in containers using Docker when it's running in the Linux systems. Then comes the heavy edge. And you'll notice that their computational power is reducing as we go from left to right. These are systems that are big enough, like that system, that can even host FPGAs inside of them. There are systems that can have GPUs, others that are a little bit nimbler, like the Mino boards that you're going to be seeing here, which actually run x64 systems, or ARM processor-based ones, which are Raspberry Pis. But that's not where it ends. There is even lighter edge. These are even smaller ARM processors. These are RTOS-based systems in many cases. What's running on your cars, what's running on your security cameras, what's running on your phones, although certain phones are really more heavy edge than others. Ideally, you like to deploy a container, but that's not always the case. In many cases, you have to go Android native. Android doesn't support containers. So you have to go native. In some cases, you're going iOS device. In some cases, you're going real-time OS. These are the OSs running on your cars, for instance. And I'm not talking about the autonomous driving component, but the one that tells you what music to listen to, the heads-up computer that comes, which is independent from your autonomous driving computer. So when we're talking about the light edge, we're talking about that type of systems. A system like the developer kit, Vision AI developer kit that we introduced, is in the light edge because it's co-located with those sensors, and it's performing all the inference in there, and it runs on batteries. Right now, this guy, it's running on batteries. So what we're going to do through our demos is we're going to be moving through the edge. So we're going to start with a very heavy edge, and we're going to start with FPGA. And for that, let me introduce Ted again, and he'll be walking us through the demo.
Right, great. Thanks, Henry. All right, good afternoon. And so as Henry talked about, as we talk about the spectrum, I'm not sure if you can see that, but there are two servers in there. And the whole idea here is as an edge device, we can put CPUs, GPUs, and then we're also announcing the ability to put an FPGA in that server rack. So you think about the requirements from an IoT edge perspective, why you might need to have that compute power on the edge. So imagine you have 50 or 100 surveillance cameras, and you want to do image recognition, image processing on all of them. GPUs are great, but also FPGAs now processing more than 500 images per second. You think about just having one chip to be able to do something like that. So the first thing I'm going to show is to go into the FPGA machine. Hold on, let me take away this. Okay, so let's. So what I have here is I'm basically remoting into a server. And if you look into the devices manager, you can see here that there's an actual FPGA device in this server. And so the way that IoT Edge works, for those of you who are not familiar, but you've probably seen a lot of sessions on this already, is that IoT Edge enables you to be able to containerize the functions and the things that you wanted to do, and then IoT Hub will facilitate deploying those deploying the configuration to the edge device, and then that edge device will pull down the containers with the right things. So you can compose the same types of pipelines in the cloud that then you can also do on the edge. So for example, the kinds of pipelines you might have would be data ingest. You might have a container that knows how to talk to a camera and ingest images. You might have a stream analytics container that does real-time stream processing of data. You might have an image processing container. You might have a anomaly detection or predictive maintenance model. These are all things you can containerize and then pull down to the edge. And so what we have here is one of these live machines, and you can see this. It's in the booths. So if you go to the IoT booth, you'll see a real live machine with a real FPGA in there running this real model. Right now, I'm just remoting into it. But basically, in this case, we have a demo that we will show, and this is basically Jabil. Jabil is a manufacturing customer and a manufacturing company. What they do is they want to analyze images of circuit boards for manufacturing defects. And so using an AI model to look at images to identify whether they're manufacturing defects or not. So what I have here is basically this model running, and I'm going to kick it up. And you can see that just by sending one thread, I'm already getting close to 60 images per second. And you think about on a CPU, you get only about 6 images per second. So right now, with just one thread hammering the FPGA on the device itself, I'm getting 10 times better performance than CPU. So I'm just going to increase the number of threads, and you can see that I can get a little bit more performance and throughput out of here. See if we kick it up even further. But the whole idea here is I just have 12 threads that's just sending a lot of images to this FPGA model. And the whole point of this is that now I can take it and I can process up to about 500 images per second all on this edge device. And so this is just an illustration of the ability to be able to give you the flexibility of putting different types of hardware on these edge devices, starting with super, super, super duper heavy server-grade hardware. So that's basically what we're able to show from an FPGA perspective. So let's go back to the deck here. And then you.
Awesome. So while I think I'm in the wrong one.
Which deck? Which slide?
6. It's okay. Okay. So you remember the picture the video I took from Dave? By the way, we're just sparsing this around because we're actually training while we're doing this. So while Ted was talking to you guys, I did a couple of things. That video that I took went into OneDrive, so I just pulled it from OneDrive. So what you're seeing here is me just leveraging FFmpeg. So you can run FFmpeg, give it the video, and it will generate frames for you. So that's how you go to about 300 frames for Dave, rather than having a whole photo session for him. Once you have the frames collected, you can use a command that we have, azcopy, that would actually take those images and connects it directly to the blob storage. So I put it on the cloud. From that point forward, any time that I want to use those images, I can just do it directly on the cloud. I don't have to upload anymore. And that's what we did. It uploaded about 233 images. Now, with those 233 images, I can now go and start the training session for that one. But I'll give you more details about it in a second. Can you go to? Great. So while we're doing this, remember this is how we collected the data, right? Now we're going to do a demo of a Minnow board, which is an Intel x64 system. It's connected to temperature sensors. And we're going to be training it with VS Code plus Azure ML. So the next step, after you've collected the data, like the way we did it, would be to, hey, go ahead and train it. So Ted is going to be showing you how to train it using VS Code and our services. When you think about Azure ML, the important thing is to remember that it's a set of services in the cloud. So you can access them from any platform where you're capable of issuing REST API commands or an SDK call. And then Ted is going to be showing you also how to do that deployment using the CLI, which we also support, onto the edge.
Okay,
Take
great.
it away.
Thanks. All right, so next up, as Henry mentioned, now we're going to take this end-to-end data science journey. So the scenario that we have is, imagine you have a factory and there are a bunch of temperature sensors. And all these temperature sensors are sending in data, and you want to collect the data and you want to predict whether there's an anomaly in the temperature that's coming through. And then imagine those temperature sensors are connected to this middle board right here. So IoT device, we went from super heavy edge to lighter edge here. But something that can still run a Docker container. And so this is the edge device that I'll be referring to. So the first step is to train our model. And so I'm going to jump over to VS Code. And here in VS Code, basically the idea here is I'm able to, as a data scientist, just code in my Python using the frameworks that I like to use, and I can just do all of that in VS Code. So in VS Code, I'm then able to connect to our experimentation service. And the experimentation service gives me the ability to bring in the compute context that makes the most sense. So for example, I may be wanting to experiment very quickly. I may want to just submit jobs and train on my local machine, on my local workstation. I just want to try different things quickly, iterate quickly with a small data set just to get a feel for the data and then start creating a model. And I can just do that on my local machine. Then, when I want to train on the larger data set with a lot more compute power, I can spin up a Spark cluster, for example. I can spin up another cluster and submit my job there. Now, with big data and big compute, I can then train my model on something like that. If I want to train a deep neural net and I want to spin up a GPU cluster with Azure Batch AI, then I'm able to spin up a GPU cluster on Azure, submit my job onto that GPU cluster, run that job, and then get the model output. So everything from here, basically what you can do is click on Submit Job, and these are the various compute targets that you have from an Azure machine learning perspective to be able to train your model. And then so the next step after training that model is to containerize it. So the output of your training will essentially give you these model artifacts. And the model artifacts could be a Python pickle file, basically the model serialized as a pickle file. It could be a TensorFlow checkpoint, just various outputs of these various frameworks. And what you want to do now is to containerize them in a Docker container. So we have a container building service. What it'll do, as you can see here, is that it's taking that model file, that model pickle file. It's taking what we call a driver file, which will enable you to define what happens every time that model is called. And then it'll containerize it. So this will be a container, a Docker container with a REST API. And now this Docker container can be deployed to the cloud. You can deploy this to the cloud or anything else that can run a Docker container. You have this REST API that you can send data to, and you can get a response back. Also included in this Docker container is the IoT Edge SDK, meaning that now if you deploy this onto an edge device, you'll be able to compose that pipeline on this edge device, such as this middle board, and then you'll be able to run that model directly onto an IoT Edge device that's incorporated with the IoT Edge runtime. So the container building does take a few minutes, and so basically what I'm going to do is just kick this off, and then I've already built the container, and so I'll show the output there. So let's go over to my IoT Hub, and in my IoT Hub, I'm going to go into IoT Edge. And in IoT Edge, I have the capability to register various edge devices. So for example, I have my middle board here. And the nice thing about IoT Hub is now I can keep track and manage all my edge devices and all the various modules and containers that are deployed. So for example, if I'm a retailer and I have 11,000 stores all across North America, I might tag various edge devices and say, these are all of my devices in California. These are all my devices in Washington. These are all my devices in stores that are in cities with over 100,000 people. I can tag them however I want. And now let's say there's a new model and a new machine learning model. I can say, deploy this model to all edge devices in California, for example. That's what I can do with this. So as you can see here on the device, you can see that I have the IoT Edge runtime. I have my temperature module already deployed and my anomaly module. If I wanted to create new modules, I can just click Set Modules here, add IoT Edge module. and basically give the name and the container registry that contains it, and then I'll be able to let it know which ones to pull down onto the edge device. IoT Edge also gives you the ability to compose routes. And so the idea here is with all these different containers, you can configure where the data is going to flow. And IoT Edge facilitates the flow of that data. So going back to that example, maybe you have an ingest module that takes in data from a temperature. You have a stream analytics module, and you have a machine learning module that does anomaly detection. So you say the temperature sensors will send data to my ingest module. The ingest module will send data to my stream analytics module. The output of the stream analytics module will go into my machine learning module, and the output of that may go to the cloud, for example. So that's what you're seeing here. My temperature sensor module is the output of this one, of the temperature sensing module, is going into my anomaly detection module, and the output of my anomaly detection module is going into the cloud. But I can also send that to another container, for example. So all of these are things that you can configure in the cloud, and then when you click submit, this JSON document will be sent down to this Minnow board, and then the Minnow board, the IoT Edge runtime and agent on here will pull down the right containers from the correct registries and instantiate them on something like this. So after doing that, let's jump over to the actual Minnow board. And this Minnow board is running Ubuntu here. And let me see if I could increase the font size a little bit here. All right. So on this actual device, I have all of the containers that have been deployed. And so you can see here, I have my anomaly detection module. I have my temperature sensor module. These are all containers that have been deployed onto these devices, and they're running and they're talking to the IoT Edge runtime. And then I can monitor what's happening on this device. So what I'm doing now is monitoring events from this Minnow board, and you can see here that it's able to detect that an anomaly was detected or things are normal, for example. So now I have the ability to be able to just kind of summarize everything that I just did. Build a machine learning model, containerize it as a Docker container, deploy that onto an edge device, and then now I can monitor these events to see whether there's an anomaly or not on this edge device. So that's the end-to-end of training, deploying a model, and deploying it onto an edge device. All right.
Great, thanks. 6. Awesome. So that was the second demo for the edge. I don't know about you guys, but first time I tried to do these, I got confused. The second time, I got confused again. So what helps me is to actually reiterate the components and what we have seen. So let's see if that helps us get. So it all starts with an idea, model creation, and you've seen how it does. When you have that model, you can deploy it. You can think of a cognitive service or the images that you create on your browser using customvision.ai as a way to create them. The path that we have just gone through, it's a little bit more complex. But in essence, we're following the same pattern. We're creating a model, we're putting it in an image, and we're deploying it somewhere. How do you go about executing it? That image needs to be run in one of the devices. You've seen those images running in 2 types of devices so far: the heavy edge and the Minnow board. You can also go and train it, and that's the process that I'm going to walk you through as well. Ted also went through that process. He did a little bit more streamlined. I'm going to go in extreme detail about how do we go about training it. So the path we're going to be following right now, remember we captured that data. We're going to be preparing and registering that model. And of course, you can go directly from there to create an image and deploy it. But we're actually going to go and create an application for that model. When we create that application, we can also go to an image and get it deployed, which is exactly what Ted just showed you. But we are actually going to go and deploy it through IoT Edge. So we're going to go directly into IoT Edge, and IoT Edge is the one that's actually going to put the application on the device. And then we're going to monitor that model and the application and add additional data. That data is going to help us improve the model later on. So that's what we're going to try to do again. So if you remember where we left Dave's images, is that we had upload those images into the cloud, and we had them ready to be used. So how are we going to consume them? Let's go to Visual Studio Code. We're going to use retrain. Oh, how does that work? That's weird.
What did you want to see?
I think it's this. Give me a second. No wonder it wasn't changing. So this VS Code, this is how you train a TensorFlow model. So extreme detail, you can see how large the code base is here. But let me highlight important parts on the code base here. So we're going to go to key model download. Do you remember the images and how we put them in a blob storage? We're first going to download those. And I'm going to move quickly on this because it has my key, and I don't want to share it with you guys. But you download those images. Those images get downloaded into the file system that you're using. In this case, we're going to be connecting to one of the VMs on the cloud that already has TensorFlow. We provision TensorFlow for you in these machines, into DSVMs, and it's going to download those images. Once you have those images downloaded, it's actually going to start training it. So it's going to start passing those images and starting to generate bottlenecks and being able to generate the tensors and all the data science component. I'm not going to bore you with the details. What's going to happen at the end is that it's going to generate a model, and that model is going to be, sorry, let's go a little too much. That model is going to be stored into this output of models, and then we have the training summaries and the labels. So two things are important to us, the model itself and the labels that are going to be generated. And notice that we're using that architecture mobile net here. So when we have those directories in output, those files, we're going to go into retrained. Those files are retrained graph and retrained labels. After we have them, those are too large to run on the systems that we're going to target next, the drone and the camera. So we're going to quantize them. So quantization is a process by which we basically reduce the operations to 8-bit operations. And we're going to be creating that new quantized model and storing it locally. The advantage of using Azure ML is that all of these files you get with the model. So when you take from a gallery, one of our examples or solutions, you get the code that was used to train it. If you go into the packages, and that's why the announcement about packages is so big. If you want to train any classifier, any Vision AI classifier, you just download the package for Vision AI that we have, and that includes everything. It includes even a sample data set for image of training. But it includes your application, it includes your training code, and it includes the evaluation code as well. Now, I could run it directly from here, or I could use another one of our surfaces, which is the Workbench. Now, the Workbench, this is a train that I had done earlier today, but I can always go here and start a new training session. So I can, and this is yet another interface. You can do this from the command line, and in fact, I'm going to do it from the command line. You can choose where to do it. Do you want to do it locally? Do you want to do it in a Docker container? Do you want to build it in the VM? And this is the VM I created. And what do you want to do? Do you want to retrain? Do you want to quantize? Do you want to test it? You can also do the same thing just from the command line. So what I'm going to do is oh, I should have made this bigger. Sorry about that. So on here, the command that I'm gonna issue is AzureML experiment submit, and then I'm gonna say that I'm targeting the VM, and I'm gonna ask it to run retrain. When I do that, what it's doing is it's copying my file into the cloud. It's putting it on that VM, and it's executing that environment. As the VM boots, the first thing that we do is we provision all of the dependencies that we had for that file. TensorFlow, NumPy, all of the dependencies. It gives me a run ID. That's how I keep track of it. And then it starts to execute. And you can see it's starting to download. By the way, the classifier we're training is a cat and dog classifier. I'm using the Kaggle cat and dog image data set. But we also added Dave. So hopefully, our classifier is going to be able to distinguish between cats, dogs, and Dave. So it's doing its thing. It's downloading the images there. And what you will notice is that this is the training. It's running. So it's going to take a fair amount of time. So what I did on the background is I kickstarted another training set. So I have finished the previous training set, and I ended up getting the 2 images. Now what I'm going to do is I'm going to target this drone with that. So how am I going to do that? This drone has a controller, which is this Android phone. That's how I control the drone. It has a controller. Now our friends from DJI, you saw their announcement, have been kind enough that they have an SDK for this drone that you can leverage both from Windows and from Android. Now I'm going to do it from the phone because Satya already did the one from Windows, and it's pretty cool. It was actually Sam, but it's pretty cool. So I'm going to do it with the phone. It's not going to be as cool, but we'll try. So the phone is not running Windows. This phone is running Android. So I'm going to create an Android app. When this finishes, when one of these runs finishes, those files, the graph and the graph file and the labels file are created, and they're deposited in my assets directory. If anybody has programmed in Android, you know that there's an assets directory where you can put components. So it's placed the graph here, and there should be labels around here, and labels there. So they were finished a few minutes ago, and this is my code. This is the sample code. If you go into customvision.ai, for instance, and you choose export to TF, it also gives you code very similar to this that you can use. So if you wanted to try it tonight, just go customvision.ai, put your images. I told you already how you can do the trick to get images really fast. Put them in there, get them trained, and get your TensorFlow. You can do that. You can get the model and the example. So what's interesting about the DJI SDK, they have great talks online, so I'm not going to bore you with the details, but what basically the application is doing is that it opens our Wi-Fi connection to the drone. That's how it controls it, but it also streams the images. Now, in order to stream it, it streams it as a YUV, and those images need to be translated to JPEGs, because if you remember, I transformed the images from Dave into JPEGs. My model only understands JPEGs. So my code is going to go and take those images, and then it's going to pre-process those images, and that's what you're seeing here, because the model was trained with images that were of a particular characteristic, particular size. What you didn't see in the training code is that that's 224 by 224 images. Yeah, they're very small, but then I don't have that much RAM here to actually put all the images. So this is going to be doing pre-processing of those images, and then I'm going to be able to run them through the classifier. Literally, I'm just calling the classifier, which incorporates those assets. So let's try it. I'm just going to run this here. Very safe passcode. And we're going to run it. So there's my pixel. And here's where you got to remember to be kind, because we did this live. We have another model to test in case this fails. But I have not seen it, so this is going to be our first time. So it's building it right now. I'm going to get my drone ready. And there we go. And now we need our trusty props for the images themselves, which they should be around here. Did you see the images of cats and dogs? No. It should have been a folder. Oh, it's right here. There you go.
I can hold them.
So let me see, how are we doing? This is the app itself. Let's see if it actually runs. Super secure. OK, that's the app. So I'm going to open the connection to the drone. And there's the drone. We're all live. That's awesome. So Dave, I'm going to ask you to come here, please, because I can't go with this. So I'm going to hit classify, which means that I'm going to begin to classify these images. So that's just the world, yes. And now that is a dog, very good. And that is a cat, and the moment of truth. That's Dave! Wait, again. It has to work. Dave, there you go. Thank you, man. Appreciate it. Woo! We dodged that one. So that's how you build it. So you can go there to home tonight, and you can build one like this. Just follow roughly my instructions. They'll be much better online if you go to Custom Vision. So going back to what did we just do? Sorry for all the back and forth with this, right? But so we trained, as I said, you can train in the web browser. Just go customvision.ai. It's a cognitive service. You can just go train it there. You can also go look for pre-trained models or examples that we have. So you go to that website, gallery.azure.ai. We have example solutions that have for both vision as well as anomaly detection and so on. You can train it both with Jupyter Notebooks, VS Code, Visual Studio, or the Azure ML Workbench that I showed you. And then you can deploy it with CLI and SDK. Then, of course, you can do that with a web browser, VS Code and Visual Studio. After that, you should be able to monitor it as well, and we'll show you that, which is basically you go into our system, and you're able to see all the different models that we have deployed, and you get information about those models. As you go on and collect this information, you will be able to get even better results with your models. I'm sorry, but this one in particular seems to looks like I'm in the wrong deck. 1 second, please. Sorry about that. OK, great. Found my place again. OK. I don't know why it keeps going back to. OK, so we successfully did the drone demo, so that's great. But what are the challenges of running these models on the edge, more specifically, right? Because so far, it seems like everything is easy. It should all work. Well, as we go even smaller to a system like this, or even smaller than that, you're going to face reduced compute. Now, reduced compute is imminent because you have much less power. So you need to add hardware acceleration. Now, the hardware acceleration, that has to go beyond your ARM and CPU. So you could go GPU. Now, the challenge is that when you go to a GPU, you don't have a common hardware abstraction for neural networks. GPUs for these devices are from non-existent to Adreno, Mali, NVIDIA GPUs. As you go down that list, it gets even more and more expensive. And then you have to face driver version fragmentation. Because you might have an Adreno GPU, but the driver that shipped because the ODM decided to put an early driver of that GPU doesn't expose it to hardware acceleration for your neural network. So you're out of luck. You have to worry about all of those components. And of course, your cost increases. The alternative is to use a neural network accelerator. Now, there are many options for neural network acceleration. And you need to be familiar with every platform if you were to do that. So how can we help you with that diversity? That's when we got together with our friends from Qualcomm and decided to tackle this by certifying support for a target platform. And you'll hear from my friend Shardul in a few minutes about why we chose Qualcomm, but we chose Qualcomm as our first partner for this. And we look to incorporate it as a first-class deployment target, meaning that you can leverage all of the tools that we've shown you today and target directly that device, as simple as any of the other systems. You will be using the same pipeline, so same training, same components, same VS Code interface, and hopefully we will enable an ecosystem of devices that use this board. So that's how we ended up with the Vision AI Developer Kit. It's a fairly beefy Linux-based system that it's going to run your models on device, on the edge. This system, you can get access to it. You just go to Vision AI Developer Kit, visionaidevkit.com, or you can see us in the booth. Because the system uses the same software pipeline, you can start leveraging our pipeline to create the models now. And there will be a limited release of training examples and trained networks that you can use soon. So that's why you should register. You'll get access to those. Even before you get your device, you will be able to leverage those solutions and those cognitive services to create your systems, your applications. Those get translated into Docker it's a version of Docker that is hardware accelerated. It will include, not Docker itself, but the image inside of, the application inside of Docker, as well as the model are hardware accelerated, meaning that they're targeting this particular platform. And they are leveraging Azure IoT Edge to reach the camera. So it's basically the same process we've elaborated for you today. The magic is happening on the device. And to tell us more about that magic, let's welcome Shardul from Qualcomm.
Henry.
Please.
Thanks, Henry, for walking us through this. Hi, I'm Shardul. I'm from Qualcomm. I'm a product manager over there. As part of our collaboration over here with Henry and the extended Microsoft team, when we thought about bringing the Vision AI Developer Kit, we said the kit needs to be more power efficient, at the same time do inferencing at the edge in a manner that it gives optimal performance. So we came up with this kit in coordination with some new platform that we were announcing. So a few weeks back, we had announced a platform called Vision Intelligence Platform. That's what we used for this kit. And in essence, the whole concept of Vision Intelligence Platform is it's based on a heterogeneous architecture. So it has an integrated ISP. It has an integrated GPU. It has an integrated display processing unit. Besides, it also comes with an integrated Wi-Fi, Bluetooth connection, and an integrated ARM CPU core, and an additional component which we call as a vector processor, or so as to say HVX, an extension of a DSP. When we look at doing inferencing at the edge, power is optimal, but at the same time, you want to get more inferences. So there are three options on this platform to do inferencing at the edge. One, you can run your fixed 8-bit precision networks on the ARM CPU, or you can run floating point 32-bit networks, precision networks on the ARM CPU. But apart from CPU, we have GPU as well. It comes with the Adreno 615 GPU. Again, on a GPU, you can run floating point 16 or 32 networks. But then we also had another core, which we call as the DSP, or the hexagon vector processing unit. That is basically the most power efficient core in the whole processor. And we intend that developers can use that core mainly for the neural processing engines. That core right now supports the 8-bit precision. So definitely once the model is quantized, it can be run on this core. In order to support this heterogeneous architecture, what we have done is we have a developer kit that we call as Snapdragon Neural Processing Engine, NPE. This is an SDK which is available on Qualcomm Developer Network. Anyone can go right now and download it. As part of this kit, what you get is a conversion tool. So once you take a model from TensorFlow or Caffe, you can convert it to a runtime for the Snapdragon processor. And then the kit provides you access to whether you want to run it on CPU, or you want to run it on GPU, or you want to run it on HVX. So we provide you that flexibility. And once you have that conversion done on probably a laptop or a machine that you have, you can load that model generally on a device. Now, in collaboration with Henry's team, as part of the whole Azure IoT Edge effort, what can be done now is you can train the model on the cloud, just how Henry did. You can train for Dave's face on the cloud, put it on the edge device through the Docker container. So now you can do the training on the fly. You can use the high compute power on the cloud, but then do the inferencing at the edge. At the same time, you can take care of privacy, reliability, as well as latency aspects if mission-critical activities are to be done at the edge. So that's where the Qualcomm QCS603 platform comes in. And then it comes with all the SDK just for the edge device. So you can have the SDK for IoT Edge. You can also have the Snappy SDK for the device. Thanks.
Thank you. Thank you, Jerez. Great. So let's see it in action. Ted, can you deploy a container? So as Shardul mentioned, they support several frameworks. If you notice, one of the frameworks that they support, it's a TensorFlow. And inside of it, the network that they support is MobileNet. So we have a MobileNet. Remember, that's why the one we trained. So we're going to deploy it onto the device. So we're going to try to switch back.
Go back to this. All right, so basically, we're going to be doing the same thing. We're back in our IoT hub, and we will look into our IoT Edge. And so you can imagine that camera is registered with our IoT hub, and this is our QCNN device right here. And this is something that I had just, because it's something that can just run various containers, I just deploy the temperature sensor model on there anyway, just to make sure that it works. But in essence, what I can do is have to deploy an IoT Edge module on here. And I'll give it the name. Just give it the name. This is an image recognition model, for example. And then give it the location of that repository. Save this. And do next here. Whoops. And then I'm just submit this. And what's essentially happening now is I'm putting together that JSON document and configuring that. I could configure the routes and say, OK, I'm going to take an image from the camera, and then the image from the camera is going to be processed in that AI module for image recognition, for example. And so what's happening now is that I'm getting status back from the camera. And right now, it's saying this image recognition is a pending deployment. And so depending on how long it's going to take, this is going down, this JSON object is going down onto the camera. The camera recognizes, and the IoT Edge runtime says, OK, I need to pull down this container. So it's going to go to that registry, and it's going to pull down that container. And depending on how long that it takes for the container to go down onto the camera, it's going to do that, instantiate that Docker image into that Docker container, and then be able to run that module.
Great.
So
in spirit of transparency, we've already trained a network that's much better than mine to run on the camera, and it's already deployed on the camera. So if we can just look at the camera. So that's the camera. It's been looking at me the whole time. So you've seen it making cameos as we go. And there's your cat. And there's your dog. And the camera is running on batteries again. So that's the Vision AI Developer Kit. And as I said, you guys can start working with it in terms of software. The SDK from Qualcomm is available. You are more than welcome to go and visit the booth register online to get access to early samples of the code for you guys to play with it. You can target the cloud initially, and when the camera becomes available, it will be able to deploy into the camera. Once again, that's visionaidevkit.com. And that's it. Okay. Thank you. If you have questions.